Imagine stepping onto a battlefield where the human eye sees nothing but absolute darkness. No moonlight, no visible horizon, no clear path forward. And yet, through a small device mounted to a soldier's helmet, the darkness suddenly comes alive. Why did the ability to see in the dark become one of the most transformative advantages in military history? Because throughout centuries of warfare, the fall of night meant the halt of movement, the blinding of command, and the hiding of the enemy. But how can a compact glass and titanium instrument turn near total darkness into a clear, visible world? This is the engineering behind the machine that conquered the night. Chapter 1. The war against darkness. Darkness has always been the ultimate veil. For millennia, commanders had to halt operations when the sun set. Human vision, evolved for daytime survival, fails completely in low-light conditions. Without enough photons hitting the retina, the biological eye cannot generate a coherent picture. Historically, military forces attempted to pierce the gloom with primitive tools: bonfires, searchlights, and flares. But these methods came with a fatal flaw. They illuminated the user just as clearly as the target, turning a light source into a beacon for enemy fire. The military value of seeing when the enemy remains blind is absolute. To own the night is to double your operational window, to move undetected, and to dictate the terms of engagement. For generations, this capability remained locked behind the physical limits of human biology, until science unlocked a hidden spectrum of light. Chapter 2. The secret that changed night warfare. The revolution began in the mid-20th century. Early military research focused on active infrared systems, devices that projected an invisible infrared beam and used an electronic converter tube to see the reflection. While innovative, Generation 0 and early systems required heavy, cumbersome equipment and powerful infrared searchlights that could be detected by opposing forces equipped with similar detectors. The true breakthrough came with passive night vision. Instead of casting light, these systems captured ambient light, starlight, moonlight, and sky glow, and multiplied it thousands of times over. Pioneered through decades of defense research, the technology evolved rapidly, moving from bulky, fragile vacuum tubes to rugged, miniaturized systems. The United States and Allied defense sectors refined these optics, transforming night vision from an experimental novelty into an indispensable standard equipment for modern operators. Chapter 3. What is actually inside night vision goggles? To understand how night vision works, one must look inside the housing. At its core, a night vision device is an intricate assembly of precision optics and quantum physics. The primary components include the objective lens, gathers incoming ambient light from the scene; the photocathode, a specialized surface that converts photons into electrons; the microchannel plate, a microscopic glass disc packed with millions of tiny channels that multiply those electrons; the phosphor screen, a coated screen that converts the multiplied electrons back into visible light; the eyepiece lens, magnifies the final image for the user's eye; the power supply unit, regulates high voltage across the internal components; the image intensifier tube, the sealed vacuum cylinder that houses the photocathode, microchannel plate, and phosphor screen working in unison. Each part plays a precise role in an unbroken chain of energy conversion. Chapter 4. How darkness becomes an image. The process defies intuitive understanding, operating at the intersection of optics and subatomic physics. It unfolds in sequential steps. First, tiny, invisible amounts of ambient light, scattered photons from distant stars or faint atmospheric glow, enter the objective lens. Second, this faint light reaches the photocathode, located at the front of the image intensifier tube. Third, through the photoelectric effect, the incoming photons strike the material and are converted into a stream of electrical energy, electrons. Fourth, these electrons are accelerated across a high-voltage electrostatic field and enter the microchannel plate. Fifth, as the electrons strike the walls of the millions of microscopic glass channels inside the plate, secondary electrons are knocked loose, drastically amplifying the signal by thousands of times. Sixth, this dense wave of amplified electrons surges forward and strikes the phosphor screen at the rear of the tube. Seventh, the phosphor coating glows brightly when impacted by the electrons, producing a sharp, visible monochrome image of the outside world. Eighth, the eyepiece lens magnifies this glowing picture, presenting it directly to the operator's eye. The iconic green hue is chosen because the human eye possesses more photoreceptors sensitive to green wavelengths than any other color, reducing eye fatigue during prolonged observation. Chapter 5. Why green? For decades, the fluorescent green glow has been synonymous with night vision. This choice is rooted in human physiology. The human eye can distinguish more shades of green than almost any other color, allowing operators to discern subtle variations in contrast, shadow, and terrain texture. Furthermore, early phosphor compounds naturally emitted green light efficiently under low-energy electron bombardment. However, technology does not stand still. Modern advancements have introduced white phosphor tubes. White phosphor provides a black and white imagery style that closely mimics natural daylight perception, reducing eye strain and improving target recognition under extreme conditions. Both systems remain in service, tailored to specific mission profiles and operator preferences. Chapter 6. The generations of night vision. Night vision technology evolved through distinct technological plateaus, each representing a massive leap in capability. Generation 0 marked the beginning, utilizing active infrared technology with large, energy-hungry external searchlights. Generation 1 introduced passive image intensification, eliminating the need for infrared searchlights, though tubes were sensitive to light distortion and suffered from edge distortion. Generation 2 introduced the microchannel plate. This single engineering marvel dramatically increased light amplification, improved image clarity, and eliminated many artifacts of earlier systems. Generation 3 revolutionized the field with gallium arsenide photocathodes. These systems achieved unprecedented quantum efficiency, delivering exceptional performance in near total darkness and rugged durability for combat environments. Modern systems continue this trajectory, integrating auto-gating power supplies to instantly adjust to sudden flashes of bright light, alongside digital sensors that blur the line between optical intensification and digital processing. Chapter 7. Night vision is not magic. Despite its legendary status, night vision is bound by strict physical laws. It is not an all-seeing magic trick. First, night vision cannot create light out of absolute, sealed-room darkness. If there are truly zero photons, such as inside a deep cave with no ambient light, traditional image intensifiers cannot function without an auxiliary infrared illuminator. Second, bright light sources can overwhelm the system, causing blooming or washout. Third, environmental obstructions like heavy fog, thick smoke, dense dust storms, and heavy snowfall scatter ambient light, severely degrading performance. Fourth, operators must manage battery life, optical distortion, a narrower field of view compared to natural human peripheral vision, and reduced depth perception. Understanding these limitations is critical to operating effectively in the field. Chapter 8. The tactical value of image intensification touches every branch of modern military operations. In navigation, ground units traverse complex terrain without relying on headlights or flares that reveal positions. In observation and reconnaissance, scouts monitor enemy movements across valleys while remaining invisible. For aviation, pilots flying transport and attack helicopters rely on specialized aviator night vision imaging systems to maintain contour flight through rugged mountains at high speeds. Special operations forces utilize helmet-mounted panoramic units to execute complex maneuvers under cover of darkness. It turns night into an operational domain. Chapter 9. Beyond traditional night vision. Military technology never rests on a single solution. Today, traditional light amplification stands alongside complementary technologies. Thermal imaging operates on an entirely different principle. Instead of amplifying light, it detects infrared radiation, heat, emitted by living bodies, engines, and equipment. Thermal imagers pierce through complete darkness, camouflage, smoke, and light foliage because they read thermal contrast, not light particles. Modern defense engineering has merged these two worlds through sensor fusion systems. By overlaying thermal data onto amplified night vision images, operators gain a comprehensive picture of their environment, seeing both heat signatures and fine physical details simultaneously. Chapter 10. The future of seeing in the dark. The horizon of night vision technology points toward even greater integration and miniaturization. Future systems focus on lighter composite materials, extended battery life, and ultra-high-resolution digital sensors. Sensor fusion is becoming smaller and more accessible, moving down to individual infantry levels. Augmented reality overlays project tactical data, navigation waypoints, and allied positions directly into the operator's field of view. Panoramic night vision housing units continue to expand peripheral awareness, eliminating the tunnel vision effect of older single-tube systems. The evolution of sight continues to accelerate. The night is no longer an impenetrable barrier. It has been mapped, mastered, and integrated into the modern operational theater. Let us return to the fundamental question. How do night vision goggles work? Light, photons, electrons, amplification, phosphor, image, human eye. A seamless chain of quantum mechanics transforming invisible darkness into absolute clarity. As military technology pushes further into the unseen spectrum, one reality remains certain. Humanity has permanently conquered the dark. Explore more classified engineering breakdowns on @helix_war.s4p. Subscribe now for the next documentary.